I know. I don't know why like half the people here do that.
Alright, so I'm Callie, I'm the president, and this is the system verification review. We'll go ahead and do brief introductions of people we got.
Hi, I'm Hayden, I'm the co-project manager of the design team.
Yeah.
I'm Faith, you hear me behind the computer. I'm the vice president of the team.
Oh yeah, I'm Darren, I'm the marketing officer.
And then we'll have our managers and leads introduce themselves as they get to their sections. Oh wait.
Jonathan, I'm the treasurer.
Yep. Alright, yeah. Everyone else will introduce themselves as they present. So we can go ahead and move on. Alright, so everyone should have gotten pizza. Also make sure that you have signed in if you have not already. I know a lot of people haven't because I got that kind of late, but yep, so we just did introduction, then we'll go over current treasury, timeline, project management, and we'll go over each of the sub-teams for progress, and then a quick summary, and go into like questions and more like that. So, let Aiden take it away.
Alright, so our primary goals for this presentation is to verify the semi-complete system. What we're going to do is when we go through the presentation, we're going to rank our systems, subsystems based on the success criteria. I'm going to ask that for audience participation when we rank those, please. And then please provide a reason why you ranked it as you did, okay? We're then going to discuss current issues and our product plan for testing. We're going to have the managers go over progress, issues, their current issues, their sub-team. So we'll cover that when we get there. And then I'm going to ask the audience throughout the presentation for feedback and ideas for improvement for each.
I'm Jonathan, known as you before, I'm the treasurer. Current treasury, so it's the same table I present every time. Each sub-teams, still good on budget. 93% spent mechanical, 81% electrical software. Both electrical and software have increased their budget since last time. We took some money away from mechanical. We can go to the next slide. This was our travel breakdown. So going to competition, we currently plan on taking 18 students? Okay, 18 students and then 2 faculty advisors. So we can, that is.
I have a question. How many tickets is NASA going to give you if you get to?
Yeah, NASA is giving 15, and so last year they only gave 10, and then we were able to get like 4 extras. So we're hoping that's the case. I've reached out to them, but they've answered some other emails, but not this one. So I don't know. I might have to go down to 15, but
I think is that 15 including the faculty?
I think so because it just says 15 passes. So
that is being considered.
Yeah.
So
no, we are reaching
you're
out.
working on it.
Yeah.
Until we have confirmation, we're just going to plan on 18. Well, it should be total 20. But that quantity should fit into 6 hotel rooms, and then we're going to go into 4 vans, same as last year. All that's based on about pricing from last year with a little bit of overestimates. The big change is that competition is actually longer this year. So we will be there for 10 days instead of I think it was 8 last year. So that was our travel costs at about $12,000. That's what we budgeted for. Hopefully it becomes less, but we'll see when we start getting better monetary values for things like hotel rooms per night and stuff like that. So that's all I have. Yeah, so
that. We also did some informal ranking for the SE paper because this design review was supposed to take place before the due date, but we had to push it back for reasons. So we did some informal ranking for the paper. We're going to do the formal ranking today, and then we're going to review this as a plan. Elections are coming up next Friday.
Tuesday.
Yeah, so during the general body meeting, we'll have elections. So anyone who applied for a leadership position will be requested to give a short speech, and then if you're running against someone, we'll basically have you'll just fill out your form who you're voting for, and that will take place over the general body meeting.
And proof of life that will do the 21st, which is I believe is 2 weeks from now, 2 weeks from Tuesday. So a week from this coming Tuesday. So we don't have a lot of time for that. We need to get the video filmed within this coming week. So I think the due date currently set by Brandon is that we finish filming and we start editing by at least Friday. So yeah, we need all hands on deck, and this needs to be done ASAP. So we'll talk more about that at integration meetings coming up. And then obviously competition's coming up fast. That is 2 weeks away, roughly. So
A month minus a day.
what's that?
A month minus a day.
Okay. Okay. So this next slide is about our current progress, and Brandon wanted to include it to just highlight how behind of a team we are. He doesn't want to. This isn't the slide assigning blame or anything. This is just to bring to light how bad the situation is currently. And he wanted to put the slide so we can keep this in mind for next year when we start actually making the project timeline, and also just when we're actually working on the robot designs for robots. So, also wants to keep in mind that there's going to be changes going forward in project management and as a team. So just keep that in mind going forward, okay? Alright, with that out of the way, we are going to talk about a robot, Melody, which I believe stands for Manufactured Excavation. I had practiced this, but it's just such a long name, I couldn't keep it in my head. This is the final CAD model of the robot, is that correct?
Barring some subtle changes, shore up some things.
And then obviously it's right there, fully assembled right before your eyes. Okay. So these are the success criteria that me and Brandon came up with. So there's like two from each sub-team. There's like weight and construction for mechanical, vision and autonomy for software, and then dust control and watt hours for electrical. We're going to go through, and each sub-team is going to present these success criteria, and then we're going to rank them. And then we have on the slides, we also have the informal ranking for the CASI paper. It goes in order as you see them. So the 3 is the weight and etc. So any questions regarding the success criteria? Anything that needs explained? No? Alright, and then done talking. So I think that leads into the weight. John, do you want to come up and talk about that?
So this table that has our starting goal of our weights for each individual system, and then our status at mid-year 2 and at our critical design review. The big change is current weight. It's brand new wheels on, weighing 50 kilograms. So that's brand new wheels are probably about 18 kilograms worth of that. So we're still sitting about like 32, 35 kilograms. But at this moment, we are at 50. All I got.
Already enough for electrical. So first off for electrical today, we'll be going over our power distribution systems as well as our communication systems. After that, we're going to let Eli take the spot for a minute. He's going to talk about our PCBs. After that, I'll finish up by talking about our goals for this year and how we're kind of done. First off, for our power distribution system, we actually designed our own batteries this year using LiPo battery cells that are 3.3 volts each. Stack those 4 in series and then 5 sets of those in parallel. That allows us to keep our robot at 12 volts and while having the capacity to handle our more current heavy components such as our motors. After that, this year we tried to put a little bit more focus on safety, so we added circuit protection in by actually adding circuit breakers this year, as well as making new power distribution terminals. Thanks to our basic mechanical team, we got to design new terminal blocks for that, so that's pretty cool. And for our communication system, we mostly focused on creating an ROI system this year, robot over internet. This was handled mostly through Ethernet cables going across the robot, delivering both power and data to all of our major components, such as our motors, actuators, and our just overdrive boxes that we have that I'll talk about in a little bit. This was mostly to make a more modular system because in previous years had to tediously put 6 data cables going to every single thing. Now we can just tie that all together with Ethernet cables to your data. If you'd like to, after the presentation, I'll be over here showing off the overdrive boxes and PCBs. I'd be happy to answer any questions anyone has.
So a little bit onto the development of the PCBs and kind of the design process. Started out over the summer, we were working out the concept for the ROI system. So then as we got into the first semester, we came up with our preliminary designs. We had a bunch of different kind of electrical sub-teams working on different parts of the PCB. And then we got them all merged together and then routed out and designed each there. We were able to manufacture that and get it tested in the first semester. And then over winter break, we made some critical changes and set out a second revision. That revision we did opt to manually assemble them. So it's a picture there with manually picking placing components. And then once we got those reflowed together, we were able to test them and start getting them out on the robot. Kind of the biggest thing to note with the SVR and design goals, the POE didn't end up coming into the final design. We had an issue with the ground loop where there's different ground potentials between the drives themselves and the PCBs because of the POE. So that's been taken out, and you can be able to see on that over there. There's just a pair of wires just injecting power directly out of the board that's releasing power from the net. So that's ended up being our final revision going with that.
Let's finish up by talking about our goals. So our 2 main goals today as electrical team were dust control as well as watt-hour usage. Just trying to conserve energy since that is a major component in competition on how we're graded now. So overall, I'd say we did pretty well this year. I mean, we have, as you can see over there, our overdrive boxes. Those are providing a lot of our dust proofing. Those are at least a 1, I would say. They keep the sand out pretty well. We have not gotten to thoroughly test them yet, so I can't say if they should be higher or not. And then for our energy usage, again, we've not gotten to test our robot yet, so I cannot say exactly where we land on that list. Our goals for next year, though, we're going to try and miniaturize everything. Because as you can see that overdrive box there, we have 4 of those around our robot. I would love to try and shrink that down next year because those are taking up quite a bit of space. I'd also love to try and shrink down or at least reduce weight in our E-box. I know mechanical has been kind of hard on us this year about that. So hopefully next year we can try and reduce weight by a fair bit. Overall, though, I'd say it's been a pretty okay year for electrical. Yeah. Do you want to talk about that?
So the two success criteria that are electricals or dust control and watt hours. So I don't. You said before that electrical watt hour didn't have like.
Yes, for watt hours, we are not able to give an accurate measurement at this time just because we have not run the full robot yet.
Yeah. So this is the informal ranking we gave was I believe, a 0 to last year based on what we did last year.
Or if we basically, yeah, last year we would have gotten a 1.
Right. So I believe we can just leave it at that. I don't think we have much. And then dust proofing, I don't think we're going to have an issue with dust proofing. I mean, John, you did mostly the one to work with dust proofing.
It's more how you can present it than the actual. So, I think overall, it's pretty successful.
I think for the electrical side of things, we have a really nice, before we even drill holes, watertight electrical box. But we put the electrical components in custom-made 3D printed boxes. I think it would be a very smart idea to make sure it's actually dust-proof next year to put it in that electrical box. I know maybe because of the size, like we have more components than what we thought, but like I think kind of we're just believing that they're dust-proof because they're just a box, but like that is an actual dust-proof box. You would score a 3, all your electrical components would put in.
It's just kind of hard to rank anything when we're not completely complete with dust proofing and method testing. So that's going to be the theme of it.
So what did you give it on dust proofing then?
I believe Brandon gave it a 2. But I can't remember off the top of my head.
And so all of your external boxes,
Pretty sure he gave us a 1 actually, but that's just because I think during competition run, I mean, we used pretty similar boxes last year to protect the motors, and those didn't have any sand in them, so like, I think, yeah.
actually they did have sand in them.
They did?
We took them off. There was the 45 minutes total that we removed the sand pit plus putting it down. There was a good, it was not dust proof. And I thought like, man, if the judges actually popped this thing open, they would take away all our, like a perfect dust proof score. Because it's not.
And like John said on he said that we're not going to make something completely just like airtight and like dust proof. Like besides the V-Box is definitely airtight. It's like for like the motor casings or based on what you said, I would probably rank it a 2 just because it's better than last year's. Probably better than last year's, especially the V-Box. As it is right now.
Yeah, I would say it's better than last year's, yeah.
Any other questions? Concerns?
Software. Do you Alright, so what are we doing in software? Currently, we are debugging the ROI package. We've made a lot of progress on there. In fact, the O drive is up and running. So the wheels can spin, we can move around. And then some of the things that we discovered while we were debugging, restructured the way that we tie it together with the Q package. Mainly, we're calling 4 different servers instead of 1 server node. Pretty easy fix. So it just kind of changes the way in which we call the services. Thank you. So a couple of errors that we came across was originally there was a type error. This has since been resolved. Afterwards, the package data type was kind of jacked up, so it was casting a float 32 into UA8. Basically, it's a different way of interpreting a number. Before that issue, there was a threading issue. There was a misunderstanding of how Ross handled threading. That was resolved. And then lastly, we need to kind of take all of what we learned from the O-Drive package and move it over to the actuator package just to shore that up. But, so that's where that all stands. Next one. Yeah, and this just kind of goes over the changes in the control node, mainly that we are calling 4 different servers under different node names to run each individual wheel instead of just sending one message out. So nothing too drastic. And, that's pretty much it for me.
Hi, so I'm Nick, the mechanical sub-team manager, and this here,
Zachary Ellis, mechanical excavation.
You know my name.
yeah, everyone knows who I am.
Okay, so beginning of the year, this is kind of, first off, this is a development over the semester and last semester of the excavation system. Started off with the kinematic sketch, changing dimensions, red and green lines represented the actuators as they changed stroke length. And then we moved over to what we had during the PDR, which was more refined kinematic drawing for the excavation system, same kind of concept as the left, instead of, well, except for the fact that we added linkages to this design. And then for the CDR, we added the actual CAD model of the excavation system. Not much has changed from the CDR to the current model, other than we mounted it on the actual robot and had some air struts added to it. The air struts will give us some more excavation strength, about 120 pounds for when we're digging. It'll also balance the buckets, or sorry, it will balance the control arms while we're pivoting up and down, so it doesn't just have a midpoint that it's kind of tilting side to side on. So that's where we're at now. Switch to the next slide. So the goals for this year were to keep a similar front loader design that we had last year, except this year we have a different bucket. In my opinion, the bucket this year holds substantially more material than last year's did. We're not going to lose material with the carrying angle that we're at. And then I don't really know.
So what's left to do for this year is add the air struts to the excavation system, as well as add in a spacer for the back corner of the bucket to make sure that we can allow the regular to curl upwards and build up better into the bucket, increase our carrying capacity. So it's a little rough where we expect our construction verbal work volume to be at this year, since all we can really do is compare to last year and also measure the volume of the bucket itself. Last year I believe was 0.015 cubic meters that we excavated. Is that correct?
One, so breaking of one is comparable to last year.
Maybe a little over 5 cubic centimeters.
And then we go to 0. 0 is really worse.
Got it. So I ran some quick calculations, and I expect the bucket itself to hold about 0.016 cubic meters for one scoop. Being a little optimistic, but that's still about less than a third of the bucket's total volume for one scoop. And if we're doing multiple runs of that, I definitely expect us to replace around a 2 or 3 on our success criteria this year. We don't have numbers for that next year. Yeah. Here's some the calculations for the expected volume that we will estimate down the bottom left. Any questions?
Also want to talk a little bit about the refinement goals for next year. Obviously, my biggest thing this year was the bucket, and this goes for everything else in excavation. Probably probably could have started a little bit earlier on manufacturing progress, which is kind of why, like you mentioned, we're a little bit behind this year. So that's one of the big things for next year, is definitely start on not just the manufacturing phase, but also the design phase a little bit earlier in the year, so that we can get this stuff on track for later in the second semester. And then at the beginning of the semester, we also had a trap design. We were looking at essentially keep some material in the bucket so it doesn't spill out in the carry position. We're going to try to do that next year. It's basically like it's a gate that moves back and forth that kind of contains the material. And then it's not on here, but the only other thing I would say I would improve on would be to use larger and less bolts instead of 500 bolts to keep things fastened together. That's one of the biggest things that I would probably change for next year. So, other than that, any questions?
Alright, so our wheel design, this was one off of our tension spoke wheel concept. I think our presented design was what was preliminary. That's what we as a group decided we would continue forward with that design. And then from critical, kind of was, we started manufacturing around critical design review. And this was, as of last week, I think. And that's the as seen there on the table. At this point, the only really remainder stuff is to really refine the length of the tension cable, and then I think we still have some. We gotta broach the axis, and then we have set screws along the inner collar. I believe we still need to put it in place, but overall, that's where the design is currently at. So, any questions there? So our goal for this year was to keep the similar funnel design for the same reliability. Really, it was to better accommodate for the excavation forces put on the locomotion. So we put a lot of time into the calculations for the torque out of our motors. So that's dust control. We already pretty much talked about that. It's pretty much all the same that we talked with electrical. In theory, they're perfect, but it's never going to be perfect. So stats with that, there's just like a single 3D print I need to add on. I think I have to redesign something on the front because we're moving the O drives. But that's super simple. Our line controls. What time is it about?
The retirement goals for locomotion are to begin manufacturing assembly sooner. Ideally, of course, we were working very consistently throughout the semester, so we're about getting our work done faster than anything. And that allows us to have more time to fine-tune and troubleshoot our designs and get that on the robot sooner as well. Also want to simplify the design next year, take what we've learned over the past couple years. We've had some very great research going on and a lot of good design characteristics we want to borrow over the years to combine into one better wheel for next year. Alright, so development of the frame for the robot here. You can see the frame has been completely assembled and is hidden behind all the wheels and excavation system and battery connectors, wires, and whatnot, right here. So we started with this initial concept. We were going to go for kind of like it was going to look like a turtle the way the box was mounted, for lack of a better word. Not on some slope in the back here. A straight tubing all the way through, side to back, cross station as well. And we were looking at potentially welding that. We backed away from that. Want to go for something easier to machine, something that's easier to maintain as well, to service, and move to this design over here. after fleshing out the 3D model. So with at critical design review, you see we have the side plates, each held on by fasteners here, here. It's real nice to just pop off when we have the connector blocks fully secured inside of here. Otherwise, it likes to fall apart. But by competition, it will be very easy to service. And currently, this picture was taken earlier this week with the excavation system out in frame is fully fastened together as shown with the E-Block coming as well. Motors and 4 corners too. So our goals for this year are to keep it similar to what we had last year, but minimalize it. Reduce as much as possible. Get rid of redundant frames, because that adds a lot of weight to the robot itself, and also obstructs kind of our movements as well. So it's fairly hard to really get frame ratings instead of hit 2 hour to success criteria. It's more about enabling our other systems to function properly. So refining goals for next year, simplify the design. Overall, for next year, we plan on using the same robots concept and just swapping out components. Make a duplicate of it, just better with what we have for this year. All right, thank you.
Alright, so there were software success criteria that we didn't really get to on the software team slides, so I'm just going to go back really quick and talk about them. It'll be brief. So software head vision and economy. Currently the rankings for them are 2 for vision, and economy is currently at 1. Don't think those are going to change at all because you only have 1 camera being currently mounted. Is that correct, Justin?
Yeah, currently. But I mean, it's pretty easy to mount the other one.
How about you have another one? Anybody have 2?
That success criteria is number of bought NASA cameras, not number of cameras on the robot.
Right. Yeah, it's actually supposed to be changed to cameras on the robot.
Oh, okay.
And it's supposed to be an indication of both. From my understanding, these success criteria were very last minute. They're not refined. So that's something we're going to project manager is aware about. We're going definitely to improve that next year. We just have to work with what we have. I also was supposed to ask because I forgot. But do you have any suggestions for success criteria? Just anyone in the audience? These work, or do you think we should change them? Just curious about some of your thoughts.
I guess this is just clarification. What does construction mean again? That's the volume that we're digging.
Yeah, it's the volume we're digging, and I've mentioned that to Brandon and Kate. I personally think the success criteria is not great because that's something we find out at competition, not really in testing. Unless you can't dig the same box.
You'd find out in testing.
It's like we have no way to measure how many 0.0 cubic meters we get. Right. We can get a weight in kilograms, but we can't get a meter cube number. We don't have the fancy LiDAR machine that they have in the arena that we can use.
You put it on a tarp and then put that tarp in a shoebox that you measure.
Is that based on a certain amount of time that we have the bucket on the ground?
Yeah, for 15 minutes.
Because that's the length of competition. So it's basically, we just took our score from last year at the berm, and that's how those were like.
15 minutes is the cumulative time of the bucket is on the ground.
No, the whole run of the so it's really like over one competition run.
Okay.
I guess when I look at the
that anything that tells you that this robot, I mean, I can see zeros in kind of some of the numbers, but it doesn't necessarily tell me that you have the wheels sitting next to the robot. I guess I can look at construction. I guess that's just going through. But it's hard to tell from there that the robot's not put together. The robot has never moved in a pit to go through and do anything. And there needs to be some success criteria to either say that these systems, how they've come together. Because this right now is not running. And I mean, when I looked at the paper, I was particularly happy with it. I kind of understood that this robot has never run from that. But I think that goes through and might also be some criteria. Is this thing put together? Is it ready to go? Is it going to be ready to go? Because that's my next question. Whenever you look at that, but does it seem reasonable to have some sort of success criteria that says that we've integrated systems together? Because right now, I'm questioning them, have you integrated systems together? Or are we still in 3 groups? We're still an electrical group, a mechanical group, and a software group, and we're not a robot.
That's a good point. Yeah. That definitely should be a success criteria. That'll basically determine if the success criteria need to be rated. Jacob, yeah.
I was going to say maybe a success criteria is for every 10 hours of driving, that you have someone practicing you have a group of people practicing, and every 10 hours you increase your success criteria by 1 point.
So, you want to have success criteria for driving hours?
Yeah, how many hours in the sand pit has it been running? For if it's less than 10, it's 0. 10, it's 1. 20, it's 2. 30 is 3. 40 plus is or whatever.
I could see that being a success criteria.
Well, I mean, last year, or no, 2 years ago, our scissor lift broke with we needed to move the robot. The robot couldn't drive, but the scissor lift broke, and that would have been very apparent within the first hour of running the robot in the sand pit. So we never really tested it, and then it broke. I mean, our system is way simplified compared to that. But I mean, it would be very easy if after 3 hours of testing, this bearing is not perpendicular to this one enough. It's really tight on here, and we wouldn't have caught that if we didn't run it through a little bit of testing. Okay, it's a very quantifiable goal as well. All these are number based. Besides the dust is not really numerical based, right? But they're number based. Hours in the sand pit is something you can measure. Okay.
Yeah, I see what you're saying. I like that a lot. Thank you. Something to say?
Yeah, an introduction before you get to those success criteria could be a matter of like a system integration, seeing like, has a tabletop test been completed via electrical and software? Can they run their components without the robot? Because I know that hasn't happened yet completely. So that's one thing. Or rather it be, do the actuators work with the code prior to the robot putting together? Having something similar to that being a prior to success criteria. Can we do this? Then we can do this. Then we can move on to these success criteria.
Okay. Yeah. So the development of the success criteria are supposed to happen at the beginning of the year or closer to that. So yeah, like I get what you're saying. We need to have the knowledge of what could even become a success criteria. Like we even have So I definitely agree, and it's definitely something we're going to change. Trying to figure out when's the best time to develop these criteria. So we're trying to work through that currently.
As soon as possible. Get that done early summer with mechanical. We work all throughout the summer. If we don't have success criteria to go off of, we don't know which one.
Something I saw in the review in the SE paper, there's a strong push for using financial budgeting as a planning tool. That'd be a criteria like sub-team, I guess, like budget utilization.
Like a goal for the budget, instead of just spending all the money, we're trying to spend a little less.
Crazy idea. This might not work as much for mechanical, but as for electrical and software, their sub-teams are very feature-based. Like, we needed to do this, and we needed to separately do this, and then the next step is to integrate them. I like the idea of, hear me out, like an inverted skill tree in a video game, where instead of starting at a center point and then working our way outwards, we have each of these 3 sub-teams with their separate features, and you get closer to a central robot as you merge features, test them, and integrate them. Just as a visual graph. I don't know how that would work for mechanical, because you guys are very numbers-based with your dimensions and other requirements.
I think it's more a matter of, is something designed, is it manufactured, is it assembled?
Yeah.
We have features, we have excavation, which we broke down to actuators, bucket, historical members like brain.
Okay, so it's big work for you.
Doable.
We have something like that. The robot and software, electrical, mechanical, and then it's actuators. It just has it's in the SE paper.
For reference, you cannot purchase more than 2 cameras at NASA.
I will talk to Brandon about that. I also looked at some other teams' success criteria. This is recent, so this wasn't when we were developing them, but it should have been. They had a lot more success criteria than just what we have, so I'm definitely open to expanding this. I just wanted to know if you guys think that we should have more than just 6. I personally think we should, but I don't know what you guys think.
Since somebody mentioned we can't actually have more than 2 cameras bought from NASA, I should also mention the watt hours. What score do we get if we get 39 watt hours? Because it's not less than 32, but it's also not greater than 40.
So that's just what happens with that is whatever amount that you
That's just a good
Yeah.
Alligators the wrong way.
Yeah. Is it supposed to be less than 40? Or is it supposed to be greater than 32?
Yeah, no, I think we probably should change 32 to 42. Yeah. I think the alligators are flipped on every line there. Anything else? Any other concerns, complaints?
I'll just say this for the good of the people. I think right now we're all feeling a little gloomy, but I've been on the team for 4 years. Every year the robot production is getting better. It should be I don't know, but when I look at that robot, I'm extremely proud of the results so far. So we're not meeting deadlines and we kind of feel like shit right now, which we kind of should be. But this robot is by far our best manufactured, easiest to work on, very simple and very future-proof. If we truly go with, we're only going to improve where we're weak and we retain the membership that we have. It's not all doom and gloom right now. You just gotta figure out some management things, and we should not just be only doom and gloom because it is put together. I don't think anything's going to break. It's simple, and it's a very well produced and pretty impressive looking robot. So we should all be proud of that. Right?
I mean, to second that, Lane has showed me the e-box from years past. Wire jungle that is. Which has been greatly improved thanks to various people on the team. Software going forward with their
Yeah. But every system on there seems very distinct, like you've been thinking about it. That if you change one thing, you don't need to change everything else to fit on it, and it's very flexible with the other sub-teams and how they want to do things. It's been, what, is this the first year after COVID for robotics, or the second?
It's like fourth. Yeah.
Okay, my point's not going to hit as hard then. But it's going to take some time to get back to where we were, and I think that future proofing is a key element of doing that.
Yeah, no, I forgot to say this when I was talking about the schedule, but despite all the deadlines, despite every hiccup we've had along the way, me and Brendan are very proud of how we're doing, as like each sub-team is doing. I'm sure, yeah, it stinks, but there's a lot of improvements that have been made, and we just want to say that we're grateful and proud. Okay. That's not, we're almost done. Almost done.
It's always grind time around this time of year, so.
I might add, like, you could do maybe have success criteria at each design review. Just benchmarks that you want to hit at each design review and see what that is. And then another thing I was thinking is, like, if you look at the rule book, I don't know if this is possible, but if you figure out how NASA scores your robot, maybe at the final design review, you could actually score your robot in the same way that NASA scores you at competition. And that way you'll, like, be like, okay, if we have this robot for against competition, here's how we estimate we'll do, how many points we'll get with NASA. And then, you can kind of gauge from there. It's like, all right, do we need more, do we need less, how do we do compared to last year? So, that's just my feedback.
Yeah, that's a good idea. I like that a lot. We had problems developing these success criteria like in the middle of the year, almost. Because like the guidebook is very vague with a lot of things, so we were trying to wrap our heads around what they wanted. But I think doing it every design review, or just having a line with our goal of the team, and then also doing like that pseudo NASA grading, that would definitely be a better system than what we've come up with right now.
Yeah, continuing off of that, do we just want to stop with the robot, or do we want to give ourselves our own grade, so to speak, with how we want papers and whatnot? The reports, outreach reports, number one. Say, this is what we think we'll get, and be conservative with that as well. Just get a full perspective on what's going on, and evaluate everything.
I have to look at the guidebook again to see exactly what success criteria are defined as, and then try to fit everything that you're talking about with that. If I can't.
I'm just saying, like, the robot is only so much of the actual grading.
Right. Like, there's other avenues for getting points.
The outreach report, graded by ChatGPT, Gemini. I got all marks. I just want to put that out there. According to ChatGPT and Gemini, I got every point. And that's a robot grading it, so it's pretty good.
I didn't have a suggestion as much as I just had a question. So the watt hours criteria, is that supposed to be like a gross overestimate? Because from our UCF runs last year, I think our highest was like 18.
22 was our highest last year.
22. So
we were trying to keep around the same spot, mostly because we switched out. We switched out our motors. We're using different actuators and our power distribution.
like, are we just automatically assuming we'll use more?
Yes.
So wouldn't that goal kind of be better to like put 3 being less than the year prior?
Quite honestly, we don't really know exactly how to scale it, just because of how much has changed between last year and this year. Because we're also assuming, the robots have completely. So,
like, either way, it'd be better for it to be as low as possible, right? So
yes,
wouldn't it be better to make like a 3 less than what we used the year prior, and then like a 2 being the same, 1 being, or I guess that would be backwards. That's kind of confusing, but I guess it would be like, I think this is kind of a hard way to judge that, but and that kind of goes with construction as well, because that's the way that NASA gives points to that kind of stuff. It's also like, a normal score based on weight. So maybe want to account for that a little bit more so we get more of an actual number.
Yeah, we were also kind of, it was a combination of just what we thought we would probably hit this year as well as last year, what we did end up getting in competition, kind of just averaging those out and seeing what we thought was good for that. Okay.
Before we finish, can electrical meet me down and show me their things, and then mechanical show me their robot before we're done?
Yeah.
Okay.
Yeah. So quick question before we're done. What is the plan of getting this to its date of proof of life? Okay.
What was the question? I didn't quite understand.
Getting ready for proof of life.
How are we getting it from this point to the proof of life video that's due here in not that long?
Oh, so yeah, mechanically, how we plan on doing that is we're using last week's wheels just to allow us to fully test the system to some capacity and a very similar environment. And we also have just some dust covers we need to get manufactured and put onto the robot. From there, I know electrical and software are going to do their testing with the full robot itself. I'll let them talk about that if they want to, though.
Right after this for software, I'm going to Express. Probably going to test the O drive module with the actual controller, and then begin cleaning up the actuator module.
And the electrical side is ready?
Yeah, since the wheels are on as of last night, we can start mounting the control modules to them.
And what do we think those other, the real wheels are going to be? Was that the part that was just ordered now? To finish that?
Yeah, we need to mainly wait for that broach to come in. I think Max said the shipping should be like sometime between Monday and Wednesday. And then beyond that, it's just cutting the lengths of cable to size and probably getting some. I know you need to drill a hole.
Allow that. Nobody else is waiting for that. Nobody else is waiting for the doctor.
I think we're all good here, unless anyone has anything else. You can talk to you but we're done here.
Yeah. Make sure you sign into attendance again. Not your county.
How does mechanical keep track of their, like, the stuff they need to do? Is it just like an Excel sheet, word of mouth? Is there anything written down?
Here's the doing it, I guess.
Okay.
I mean,
how do you plan it out?
Robotics, once we get everything wired up, we've got power distribution down here, energy monitoring, safety, and then our data and communications up here. And then we've got example here of our O-Drive module. And then here's the card that's mounted inside.
Thank you. Can you take me through this?
What?
Can you take me through this?
Yes.
Just be loud.
Where are we starting? So up right here on our robots this year, we have our excavation system featuring 2 control arms, 2 actuators, and our bucket as well, which is connected up via a linkage to get us a little more range of motion. And if you slide on over here, we have our wheels recycled from last year. So for proof of life, just to make sure we can get things rolling and get a video out the door as soon as possible. And moving on over to here, we have our excavation frame, as we call it, which supports the E-box and the excavation system up front and bolts directly onto the locomotion frame. Peek inside here, you can see our motors, Rev Neo Vortexes. We have 4 of them. These
this is an example of our motor controllers. There's dust proofing involved there. E-box is up top, and we plan on having a battery tray very soon running through here. Just have to print and mount that.
Can you show me the new wheel?
Don't worry.
Technically, just as a full cycle.
Yeah, it's obviously because we've been approved that life video like that.
So here we have an example of our wheel design for this year. It's not fully assembled. We still need to connect up the remaining cables, acting as the spokes. You can see we have a suspended hub going on here to help reduce weight. And then around the outside, which is what we're most proud of this year, is we have a rim on each side and then a stamped sheet metal grouser, which we are doing in 2 stages, completely in-house. We take our 2-dimensional grouser, put it into our die, and then press it down to get this shape. We have these flanges coming out now. After that, we move it over to stage 2, as you can see here. We have the grouser locked into this die here to help prevent bending during the process. And we just press it straight into the die. That gets us this shape, which we can then mount directly onto the wheels. Yeah, really cool design that we're really proud of.
I took some other pictures and put them in event photos. Should have showed like all the different.
All right.